Global warming is forcing many commercially important fish stocks to abandon their traditional habitats and migrate to new areas, often crossing international maritime boundaries from exclusive economic zones (EEZ) into the high seas. This mass migration of marine life is driven primarily by rising ocean temperatures and other climate-related changes, leading to significant ecological, economic, and geopolitical consequences. The science behind the shift: fish, being cold-blooded creatures, are extremely sensitive to changes in water temperature. As the oceans absorb excess heat from the atmosphere, they are warming at an unprecedented rate. Fish species are responding to this by moving to cooler waters in a phenomenon known as thermally driven migration. Poleward movement is the most common trend for fish populations to shift toward the Earth's poles, where temperatures are more suitable for their survival and reproduction. Deeper waters: some species are also moving to deeper, cooler parts of the ocean. Changes in habitat: ocean warming is also disrupting marine food webs. For example, some prey species, such as certain types of copepods, are moving poleward, forcing their predators, like Atlantic cod, to follow suit or face starvation. Impact on national waters and the high seas: this climate-driven relocation of fish stocks creates a scenario of winners and losers among nations. Losing nations: countries in tropical and subtropical regions are projected to lose a significant portion of their fish stocks as species move away from their warming waters. Many of these are developing nations that heavily rely on fishing for food security, income, and employment. This migration can lead to reduced catches, economic hardship for fishing communities, and a loss of a primary protein source for their populations. Gaining nations: in contrast, countries at higher latitudes, such as those in the Arctic and parts of Europe and North America, may see an increase in the abundance of certain fish species as new populations migrate into their waters. This could create new fishing opportunities and economic benefits, but it also presents challenges for sustainable management. The high seas: as fish stocks move out of national EEZ, which extend to 100 nautical miles from a country's coastline, they often end up in the high seas, the international waters that belong to no single country. The lack of comprehensive, binding regulations in these areas makes these fish populations more vulnerable to overfishing. Geopolitical and management challenges: the movement of fish stocks across political boundaries complicates established international fishing agreements and creates new sources of conflict. Disputes and conflict: historical fishing quotas and treaties are often based on the assumption that fish populations will remain in their traditional locations. As species shift, these agreements become obsolete, leading to disputes over who has the right to fish for a shared resource. An example of this is the mackerel wars that arose when Atlantic mackerel, a shared stock, shifted their migration patterns. Fisheries management: managing these transboundary stocks is incredibly difficult. Effective conservation requires cooperation between all nations that share a particular fish stock, but with species moving from one country's EEZ to another and into the high seas, this becomes a complex, multi-layered problem. There's a risk of a tragedy of the commons where each nation tries to catch as much as possible before the fish move again, leading to overexploitation and the collapse of the stock. Vulnerability of migratory species: highly migratory species such as tuna, which already travel vast distances, are particularly affected. Their movements are becoming less predictable, making it harder for fisheries to track them and for international bodies to set effective catch limits. The path forward: addressing this challenge requires a coordinated global effort. International cooperation: nations must work together to create more flexible and dynamic fisheries management plans that can adapt to changing fish distributions. This includes establishing new treaties and strengthening existing ones to ensure sustainable fishing practices in the high seas. The recent High Seas Treaty, while a step in the right direction for marine biodiversity, needs to be complemented by robust, species-specific fisheries agreements. Scientific research. Continued and expanded scientific research is crucial to accurately predict how fish stocks will move and how these changes will affect marine ecosystems. This data is essential for informing policy decisions and developing effective management strategies. Adaptation and mitigation. Nations that are losing their fish stocks need support to adapt their economies and find alternative livelihoods for their fishing communities. Simultaneously, global efforts to mitigate climate change and reduce greenhouse gas emissions are the only long-term solution to slow and eventually halt these disruptive shifts in marine life.